In this video, I'm going to chat about the difference between a single segment position, two single segment positions, and composite position. So I got a simple part here, just a block with some holes in it. Now we've got, as always, we'll identify our datums, datum C, B, datum A, they're all planes. So our origin is going to be right in the corner of the part for all of our measurements. We've got basic dimensions coming from our datums, where our measurements will come from. We've got 4 holes, 0.5 plus or minus 20 thousandths. And now we've got 3 options for our position. So we'll talk about number 1 first. Position of 30 thousandths at MMC, A primary, B secondary, C tertiary. So in this, our tolerance zones are centered on the basic dimensions that come from the datums. Each tolerance zone is 30 thousandths diameter, centered on the basic dimensions that come from the datums. The axis of the part must lie within those tolerance zones, okay? So that keeps the holes as a pattern to the datums. Now, that can be restrictive depending on how big the part is. Say this part was 10 feet long, right? And you've got you're measuring from datum C over like 10 feet. It could be very difficult to get within 30 thousandths over a long distance. So this is a really little part, but larger parts, you often use composite or 2 single segments so that you can release requirements and let the pattern of holes float around the part as long as they stay a pattern. So whatever's going to mate up with this part needs to mate up with the 4 holes, maybe not necessarily have anything to do with the datums. So let's look at number 2, and I'll sweep this. Number 2, we've got a position of 80 thousandths at MMC to A, B, and C. Let's look at that first. So it's going to be a larger tolerance zone. $80 thousandths to A, B, and C. So that's the exact same thing as we just had before, just a larger tolerance zone. We're still coming from the datums. Now, the second one here, 30 thousandths at MMC, but only to A and B. Now, datum A only controls the perpendicularity. It has nothing to do with location. So datum A is over here. It's just saying that the hole needs to be perpendicular to that within 30 thousandths, okay? But this datum B right here has location involved. So we measure to A, B, and C. Now we have this 30 thousandths tolerance zone. We have to measure from datum B. So the tolerance zone, and this is where it gets a little tricky, and I hope you can kind of see this, it has to be within 30 thousandths to datum B, but not to datum C. So your tolerance zones within this 80 thousandths can float left and right, all within the whole 80 thousandths. But they cannot float up and down more than 30 thousandths. So you've locked it in translation and rotation to datum B, okay? So that's what single segment does, translation and rotation. Just like I always try to mention, look at the datums, that's where you're measuring from, and you can figure out how the part is measured, right? So there is no datum C in this 2 single segment position, so we don't measure from datum C. It doesn't matter. It has nothing to do with that second feature control frame, okay? So we've controlled the pattern and to datum B, translation and rotation. Now, the next one, the composite profile, works a little different. With the composite profile, we've still got this 80 thousandths that works the exact same as before. So I'll draw those. This 80 thousandths to the datums, no change there. But the bottom one 30 thousandths to A, nothing changes there, still orientation, but to B, composite indicates that now translation does not apply, only rotation. That's the big difference. For the second feature control frame down here, the feature locating tolerance zone framework, you don't have to have translation to datums. Means you don't measure from the datums, right? It just means that your tolerance zones have to be within those 80 thousandths, and they have to be oriented within 30 thousandths to B, but they're free to float up, down, left, and right, as long as they're not twisted in this direction, okay? If you didn't have B here, if you just had A, the tolerance zones could tilt, right? They could be anywhere within that 80 thousandths. B just locks them in rotation. The reason you only need, B is because with the being parallel to B is the same thing as being perpendicular to C. So you only need a maximum of 2 datums in this bottom feature control frame. That's why you never see 3. You can have 0 if you wanted to release the orientation to A. Occasionally, you'll see no datums in the bottom one. That's just controlling the pattern to itself, right, 30 thousandths, and then no orientation. So the holes could be, that just means that holes now could be tilted up to 80 thousandths. So you almost always see A called out or the primary datum just to control the orientation. So that's it for this video. Real quick talk about the difference between the 2 single segments and the composite. The biggest difference is with the composite, you're not measuring from the datums. They just control orientation, whereas 2 single segments, you're measuring from and calculating your basic dimensions on at least 1 datum. Okay? If you enjoyed the video, please like, subscribe, comment down below. I'll try to make more of these coming soon.